Okay, here I am. Doing Algebra 2 work. Let's see. Okay, so this is basic matrix operations. But let's see, I have to share my screen, right? Okay. That appears to work. I'm very new to this, of course. Okay, so basic matrix operations. And here, to begin with, I am to add this 3 by 2 matrix to this other 3 by 2 matrix. And the way that we add matrices is component-wise. Component-wise. And what that means is this component here, for example, obviously corresponds to this component here. And so to get this component here in the output, we just do -1 plus 6, which is which is 5. Okay, so let's do it then. All right, 3 add 0 is 3. 6 add -1 is 5. -1 add 6 is 5. -3 add 0 is -3. -5 add 2, that would be -3. And -1 add 3, that would be 2. And that is the sum of this pair of matrices, this pair of 3 by 2 matrices. And here we have a pair of 2 by 3 matrices, and we have to find their difference. And we do it in the obvious way. So we're going to do -5, take 6, which is -11. Then 2, take -5, which is 2, plus 5, which is 7. -2, take -6, which is -2, add 6, which is 4. 4, take 1, which is 3. -2, take 3, which is -5. And 0, take -3, which is 0. Add 3, which is 3. Next up, down here in question 3, we have scalar multiplication. Scalar multiplication. We are to multiply this 2 by 3 matrix here by the number -5. And what that means is multiply each entry of the matrix by -5. Okay, so 5 times -5, and we get -25 in this spot right here. 6 times -5, and we get -30 in this spot right here. And you just continue on like this. -4 times -5 is 20. Then comes -20. Then comes 10. And then 5. And that completes it. Over here we have a 2 by 2 matrix, also called a square matrix of order 2. And we're to scalar multiply by -5. So we do just like we've done before. -3 times -5 is 15. 0 in both of these entries here. And -5 times 5 is -25. Now we are to add this pair of 1 by 2 matrices. And we do so component-wise. 4 add -2 is 2. 2 add -6 is -4. And we're finished. Scalar multiply the column matrix or column vector by 5. Okay, that will just give me 20 here and 15 here. No problem. Scalar multiply the row matrix or row vector by -5. No problem. This will be -5, 10, 5, and -10. And for this 3 by 2 matrix here, to scalar multiply it by 5, we're going to get a 3 by 2 matrix as well. And we're going to have, let's see, 25, 5, and 5 going down the first column. Then 5, -10, and 10 going down the second column. But what's happening here in question 9? We have to multiply this matrix, which has algebraic entries in the algebraic entries, by an algebraic scalar. So what do? Well, we just do like we did before. -2u multiplied by 7u. That should be -14. That's fine. And then u times u, what's that? U squared. And that sorts out the first entry. Multiplying -2u by 7u, we get -14u squared. Next, what about -2u multiplied by 3w squared? Well, that's going to be -6. That's -2 times 3, -6. uw squared, just like that. -2u times 5u is -10u squared. -2u times 5 is -10u, just like that. Here we have a 2 by 1 matrix added to another 2 by 1 matrix, and so we just go component wise. 2 add 5 makes 7, 4 add 6 makes 10. Question 11 is very much the same as before. Multiply each entry in this column matrix by 4. So we're going to have -16, 12, and -20. Here, the entries are algebraic, but it's really no problem. Just go along component-wise. So, -4n add 4 is -4n add 4. N add m add -5 is n add m take 5. -2n add 3m, just write it down. And -4n add 0, just write down -4n. And that's it. That's all you do. A pair of row matrices, adding component-wise, we're going to have 3, -7, and -6. And for these column matrices, x add y, take 5 on top, x take 6, take 6xy on the bottom. We'll scalar multiply this column matrix by 4c. So we're going to have 0 here, 24c here, 0 there. Now what's 4c times 3a? Well, that would be 12ac. Bingo, we did it. And now we're going to scalar multiply this square 2 by 2 matrix by -3y. Okay, -2x times -3y is 6xy. -3y times -y is 3y squared. -3y times -4y is 12y squared. And -3y times -3x is 9xy. Wonderful. Problem 17. Just multiply this column matrix, the entries of the column matrix, by 3. So 2u becomes 6u, v squared becomes 3v squared, u becomes 3u. No worries. Now we have to subtract this matrix, second matrix, from this first one. Hold on. This has 4 entries and this has 3. No, look carefully. We have 1, 2, 3, and 1, 2, 3. This is why gaps are very important. So negative x take 1, take y. Well, that would be negative x, take y, take 1. Okay, who's in the middle? Negative 2x minus minus 2. Well, that would be negative 2x plus 2. Great. What about at the end? Negative 5y minus minus 3x. Will that be negative 5y plus 3x? No problem. Now here, we have to just simply go straight across and add these column matrices to each other. So negative 6r at t, add 6r. Oh, just t by itself, a solitary t. Negative r, add negative 4t. Well, that would just be negative r, take 4t. 6s, take 3r, add 2, is on the bottom. That's great. What about over here? This would be z, take 5, take 3, y. Z, take 5, take 3y. This here would be negative 6, add 3z. I'll put a bar through my z so it doesn't look like a 2. Here, negative 1, take 6z, add 5, add z. So that's going to be 4, take 5z. And down here, just 3y, add 4z. Great. Here we have to scalar multiply and then subtract this matrix over here. So I'm going to do that all in one go. So 5 times 6 is 30, and 30 take 1 is 29. Great. 5 times 1 is 5. Take 6 is negative 1. 5 times 2 is 10. 10 minus minus 6 is 10 plus 6, which is 16. 5 times negative 6 is negative 30. Negative 30 take 6 is negative 36. What about over here? We'll follow BIDMAS. First add the matrices, then multiply the entries by negative 5. So 0 at 2 is 2. 2 times negative 5 is negative 10. Negative 2 at 0 is negative 2. Negative 2 times negative 5 is positive 10. 5 at 2 is 7. 7 times negative 5 is negative 35. And that completes it. And now we have a first matrix minus a second matrix minus a third matrix. So let's do it. They're all of the same order. They're all 2 by 2. So it's valid. So we're just going to do 5 minus minus 6 minus 5. So that would be 5 plus 6 minus 5. So that would be 6. Next up, 3 take 0 take 4. Oh, so you mean minus 1? That's right. Next, 5 take 1 minus minus 2. So that would be what? 4 add 2, so 6. And then 1 minus minus 4 minus minus 6. So 1 add 4 add 6. That's right, which is 11. And here, finally, we have a 3 by 2 matrix plus another 3 by 2 matrix, but this one is scalar multiplied by 5. So we're going to do it all in one go. We're going to do 1 at 5 times -4. So that'd be 1 take 20, which is -19. Then 1 at 5 times 6, which is 31. Then 6 at 5 times 1, which is 11. Then -4 at 5 times 1, which is 1. And guess what's going to be on the bottom? Just 5 times -4 and 5 times -1, because we have a pair of zeros here. So that's all handled all well. Okay, so what shall I do? Well, I'll save it. I'll just save it to my desktop. Great. Now, the thing is, I actually don't know how I sound right now. I have my microphone there, the Blue Yeti one, and I have it at medium setting, but I have no idea how loud I sound. So I'm going to end the stream temporarily and then hopefully be back and test it out. Or perhaps I could look up my stream on my mobile, rewind it a little bit, and then check it out. But for that to be successful, I have to first mute here. So I'm going to do that right now. Okay, that appears to be fine. Therefore, we can continue. So, where should we go? Let me share my screen. That's great. Recursive content, great. Like Matryoshka dolls. And let's do matrix multiplication next. We'll open it up in journal, XOURNAL, right here. And we'll make it all big. And we'll do some matrix multiplication. Why not? Nice and relaxing. Great. So, how to matrix multiply? How to matrix multiply? What am I doing? Wait, is this sharing my screen? It is. Okay, great. So we have a 2 by 2 matrix on the left and a 2 by 2 matrix on the right. And when you matrix multiply them, you're going to get a 2 by 2 matrix as a result. That much is clear. But what are the entries going to be of this 2 by 2 matrix? For the first entry, for the entry that's in the first row and the first column, it's going to be the first row times the first column. But wait, what do I mean by times? I mean the dot product. Okay, so perhaps you don't quite know what that is. So I'll tell you how to do that. 0, 2, that's just a row matrix. And here is a column matrix, 6, 3. And when you multiply these together, when you dot multiply these together, you're going to get 0 times 6 plus 2 times 3. That's 0 times 6 plus 2 times 3, which is 6. And that's what you do. You get a 6 right here. How would I get the entry? Let's just say I have a massive 10 by 10 matrix multiplied by another 10 by 10 matrix. You would never do this by hand. You would get a computer to do it. But let's just say that that's the case. One 10 by 10 matrix multiplied by another 10 by 10 matrix. The output will be a 10 by 10 matrix as well. And how do I get the entry that's in row 3, column 5? Row 3, column 5. What you do is you multiply row 3 by column 5, the third row of the first matrix by the fifth row of the second matrix in the way that I just described. So that would involve 10 itty-bitty multiplications and additions just to get that entry. And then you have to do that 100 times over. So you can see why I would get a computer to do it. Okay, so who's going to be in this box right here? Well, that would just be 0, 2, dot multiplied by -6, 0. And the result of that is 0. That's the first row times the second column to get the entry in the first row, second column. It's very logical when you think about it. Okay, what about down here? That's going to be the second row times the first column to get the entry in the second row, first column. So -2 times 6 plus -5 times 3. That's going to be -12 at -15, which is -27. -27. Then, what about, lastly, this entry right here? Well, that's -2, -5, dot multiplied by -6, 0. So what? 12 add 0? Correct. Just there like that. We'll get on to the answers, and we see it's fine. 6, 0, -27, 12. 6, 0, -27, 12. For matrices, they're highly impractical to read out loud, but if you have to, go row by row from left to right and have an audible pause from one row to the next. Okay. What about this here? Well, this is a 2 by 1 matrix multiplied like big matrix multiplication multiplied by a 1 by 2 matrix. Is it valid? Can it be done? The answer is yes. And why so? Because this pair of numbers agree. This pair of numbers right here agree. The two ones on the inside. That's how I sort of remember it. But if you want to be formal and official, you have to say the amount of columns in the first matrix has to match the amount of rows in the second matrix. Okay, but how do we actually do it? The resulting matrix is going to be 2 by 2. And to get the entries, you're going to do first 6 times -5 to get -30. Then 6 times 4 to get 24. Then -3 times -5 to get 15. Then -3 times 4 to get -12. And there you go. Sometimes matrix multiplication is not valid, not defined. Like, you can't do a 5 by 7 matrix multiplied by a 10 by 11 matrix. The dimensions don't agree. This 7 does not agree with this 10. So you can't do it. You can't do it. But here we've got a pair of square matrices, a pair of 2 by 2 matrices, and the matrix multiplication is defined and valid. It's exactly the same thing as before, so we're just going to try and do it. Negative 5 times negative 2 is 10. Negative 5 times negative 3 is negative 15. So it's going to be 10 add negative 15, which is negative 5. Next up, negative 5 by this pair here. So 15, take 25, which is negative 10. Then negative 1, 2, scale them, dot multiplied by negative 2, 3. So 2 add 6 makes 8. Then 13 will be there. This one is defined and really much the same. So we'll just see how much we can do in our head. That would be negative 13. This would be negative 19. Negative 11. And negative 1. I believe. Okay, we have a 3 by 2 matrix multiplied by a 2 by 2 matrix. Is it well defined? Is it valid? Can we actually do it? Yes, we can, because we have a 2 here and a 2 here. The pair of inside numbers agree. Remember, it's row by column, like RC, remote control. You get me? That's great. Okay, and how big will the output matrix actually look? We'll find out, won't we? 0, 5 times negative 4, negative 2, that's negative 10. 0, 5 times 4, negative 4, that's negative 20. And we're done. We're done with the first row. Negative 3, 1 times negative 4, negative 2 is 12. Take 2, which is 10. Negative 3, 1 times 4, negative 4 is negative 12. Take 4, which is negative 16. Done. Negative 5, 1 times negative 5, negative 2 is 20. Take 2, which is 18. Done. Negative 5, 1 times 4, take 4, negative 4 is negative 20. Negative 4, which is negative 24. Done. Okay. What are the dimensions of the product of a pair of matrices? Well, they appear to be the two outside numbers, like 3. This is a 3 by 2 matrix right here. So over here, for example, wait, is this valid? Well, yes, it is, because this is 2 by 3, and this is 3 by 2, and the two inside numbers match. And then we're going to get an output of a 2 by 2 matrix, a square matrix of order 2. All right, let's do it. 535 dot negative 4, negative 3, 3 is negative 20, take 9, add 15. So negative 29 add 15, which is negative 14. 535 dot 24 negative 5 is 10 add 12, take 15, which is 22, take 15, which is 7. 150 dot negative 4 negative 3 3 is negative 4, take 15, add 0, which is negative 19, I believe. Then 150 dot 2 for negative 5 is 2 at 20, which is 22. Let's check this. So it reads negative 14, 7, negative 19, 22. Let's check it. Okay, we have some disagreement here. We've got to sort that out. 535 dot 2 4 negative 5. Let's see. 10 at 12. Take 25. Well, 10 and 12 is 22. 22 take 25 is negative 3. Ah, I see. My mistake. Okay. What's next? We have a 3 by 1 matrix multiplied by a 1 by 2 matrix. So it's going to have a 3 by 2 result. And it's quite straightforward. You just do 1 by 1 multiplications to really get the entries. So negative 5 times 3 is negative 15. Negative 5 times negative 1 is 5. 6 times 3 is 18. 6 times negative 1 is negative 6. And zeros on the bottom. Here, we've got a 2 by 3 matrix multiplied by a 2 by 3 matrix. This is not defined because the 3 and the 2 do not match. What about in this position here? A 3 by 2 matrix multiplied by a 2 by 2 matrix. So the result will be a 3 by 2 matrix. And we just go ahead and compute. Negative 3 take 5, or minus 3 minus 5 is minus 8. 18 take 4 is 14. 3 add 30 is 33. Negative 18 add 24 is 6. 6 take 30 is negative 24. Negative 36. Oh, whoops. Am I making errors here? I should sort this out. So that's 6 take 30. That's fine. Okay. Negative 36 take 24. Oh, so you mean negative 60? That's fine. Here we have a 2 by 2 matrix and a 2 by 1 matrix. So the output will be 2 by 1 and defined. So 5, 4 dot negative 4, 3 is negative 20 at 12, which is negative 8. 2 negative 1 dot negative 4, 3 is negative 8 take 3, which is negative 11. Fine. Next up, here in problem 11, looks like quite a bit of work. A 4 by 3 matrix is being multiplied by a 3 by 2 matrix. The inner numbers here agree. The number of columns in the first matrix matches the number of rows in the second matrix, so it's valid. And the output will be a 4 by 2 matrix. I'll put an arrow there. So a 4 by 2 matrix, like that. Make enough room for it. Okay, so we just compute and proceed. Minus 6, add 5, minus 6. So So that's minus 12 add 5, which is minus 7. Then comes minus 5, minus 6, 0. So minus 11. Then 30, add 10, take 30. So 10. Then 25, take 12, 0. So 13. Then 36, take 25, add 6. So 42, take 25, which is 17. Then 30, add 30, which is 60. Then negative 30, add 30, add 0, which is 0. Then negative 25, take 36, which is negative 61. Okay, here we have a 4x2 matrix and a 2x3 matrix, and the result will be a 4x3 matrix with 12 entries, but fortunately they're simple to figure out. 4x3 matrix, yes, so it will be quite beefy, quite big. So now to figure out the entries. So we're really just going to go row times column. So negative 4, add 12, makes 8. Then 4, just simply 4. Then negative 4, add 18. Also 14. Yeah, that's fine. And so remember, this is a 4x3 matrix that we make. So we're done with that first row. Next step, a little bit faster now. Negative 8, take 6 is negative 14. 8 at 0. Negative 8, take 9. Then 10. Negative 10. And 10. Great. Then 8 at 12, so 20. Negative 8. And 26. Wonderful. Who is here? We have a 1x2 matrix multiplied by a 2x2 matrix. They agree upon the inner entries. So it's going to be a 1x2 as a result. But what will it look like? We'll have a see. So it's like 2 times negative 5u, which is negative 10u, plus negative 5e times 0. So really, it's just negative 10u. Who's next? 2 times negative v, so negative 2v. Take 30v, which is negative 32v. Wonderful. And last here, in straightforward computations, we have a 2x2 multiplied by another 2x2, which is going to give us a 2x2. But the entries could be huge because we see algebra. So let's just go ahead and figure it out. 16x add 2y squared. 16x take 2y squared, rather. That's the first entry. Who's next? 20y. And who's here? 8x squared take 8y. And down here, nothing, add 20, so 20, so fine. Write an example of a matrix multiplication that is undefined. Okay, We all know how to do this by now. If you have like a 5 by 7 matrix multiplied by an 11 by 10 matrix, it's undefined because the inner numbers here, 7 and 11, do not agree. So what would be the absolute simplest case that I could come up with? You can't have 0, like 0 rows or 0 columns. That's just not allowed. So I'm going to put a 1 here and a 2 here. Okay, maintaining the spirit of simplicity. I'm going to have 1 by 1 and 2 by 1. A 1 by 1 matrix? Such a thing does exist. And in the 1 by 1 matrix, I'm going to make it as simple as possible. The entry as simple as possible, so let's just say 0. The 2 by 1 matrix, the 2-row, 1-column matrix, I'm going to make that as simple as possible. So here we go. 0, 0. That is undefined. Undefined. Perhaps I could have put 1 in the entries if you consider 1 to be simpler than 0. 0 was suddenly invented after 1, or the recognition or the understanding of 0. Let's see. Problem 16. In the expression A dot B, if A is a 3 by 5 matrix, then what could be the dimensions of B? It will have 5 rows and any number of columns that you like, as long as n is a natural number. A counting number bigger than 0. And that really solves the whole lot. Okay, so we'll just close this down and save our work. And that's fine. Fine and dandy. Now let's see, what do we have here? All matrix operations. That looks good. Let's open that up. Hold on, excuse me. First, let's just have something to drink here. Let's also check on the stream to see if it's still running. It is. 42 minutes as well. Okay. Let's do it. But prior to that, a small drink of water. What good water. So, simplify these and write undefined for expressions that are undefined. Okay. First, we have a 2 by 2 matrix multiplied by another 2 by 2 matrix, which is totally fair and totally defined. We already know how to do that now. So 2, -1, dot 4, -3. So that'll be 8 add add 3, which is 11. Then 8 add 5, which is 13. Then -24, take 3, which is -27. Then -24, take 5, which is -29. What next? Well, we have to add a pair of matrices here and then multiply by the 2 by 2. So we'll do that. We'll do 2, 6, -6, 4. And simply add these together. So we get 6, 5, -4, and 2. And then scalar multiply. So we'll have 12 take 24, which is -12. 26 dot 52, that's 10 or 12, which is 22. Negative 64 dot 6 negative 4, that's negative 36. Take 16, which is negative 52. Negative 30, add 8, so negative 22. Great. Wonderful. We did it. A 2 by 2 multiplied by a 2 by 2. That's fine. We're going to have 3 take 15, so negative 12 in the first entry. Negative 6 in the next entry. Negative 15, add 15, so 0 in this entry. 30 in this entry. All good. Now, let's see here. So we have a 2 by 2 multiplied by a 1 by 2. Sorry, a 2 by 2 multiplied by a 2 by 1, which is hunky-dory. That going to give us a 2 by 1 as a result. But then we have to add it to a 4 by 1, but this is undefined. Sorry, can't do it. I certainly hope that sort of computer algebra systems which do this check that the dimensions all match up and everything is defined before they do any computations. Otherwise, that would be very wasteful. But perhaps they assume that in most cases that it simply is defined and it would be not so worthwhile checking. Who knows? I may know in the future. So here we've got a 4 by 1 added to a 4 by 1. We just go component-wise straight across. So negative 6 there, 3 there, negative 6 there, and negative 1 right there. What about in this case? Best to do the matrix multiplication first. You don't want to be you don't want to be multiplying by bigger numbers, do you? No. So here we go. It's going to be 6 at 6, so 12. Then negative 18 at 24, so 6. Then negative 2 take 4, so negative 6. Then 6 takes 16, so negative 10. And multiply everything by negative 4. So negative 48, negative 24, 24, and 40. Wonderful. And what do we see here? Well, we see a 2 by 2 multiplied by a 2 by 3. So that's fine. We're just going to get a 2 by 3 as a result. And then we've got to add it to a 2 by 3. So that's also fine. So to save handwriting, we'll just work out what this is here. And we can do that now quite simply. It will just be 3 there, 9 there, 13 there. What about down here? 1. Then negative 35. Then negative 2. And please add it to that matrix right there on the left. That will be 6, 10, 16, 1, negative 30, negative 5. Here we are to add a pair of 3 by 1 matrices and then scalar multiply by negative 5. So let's do that. So we're going to add them first. So 4, negative 5, negative 2. Scalar multiply it now by negative 5. And we're going to have negative 20, 25, and 10. All done. Right. We've seen this before. Multiply the 2 by 2 matrices first, then add them to that matrix there. But don't bother writing out the matrix again to save handwriting. So -5, -1 times 3, 3, 1. So -15, take 1. So -16. Great. -30, take 6 is -36. -12 add 2, so -10. -24 add 12, so -12. And add them. Add that matrix to that matrix right there. And we'll get this 2 by 2 matrix, which is -17, -37, -16, -9, and we're done. What about here? We're going to have a 2 by 1 matrix as a result. I think you can see that. So it's really just -2 take, or -2 add 18, which is 16. Then -6, and we do nothing to it, basically, so that's fine. So who is here? We can really just do this in our heads. So 6 add 4 is 10. 10 take 1 is 9. 10 take 3 is 7. 0 add 6 is 6. -10 add 3 is -7. 12 add 2 is 14. And we're done. And here, well, if we add this pair of matrices, we're going to get a 2 by 3 matrix as a result. And a 2 by 2 multiplied by 2 by 3 is going to give us a 2 by 3. So it's probably better to just add them first. And we'll do that. So we're going to just get 8 minus 9, 0, minus 1, 8, minus 3. And we'll put the matrix in front of it, the 2 by 2 matrix in front of it. And what will we get as a result? -40 take 1, so -41. 45 add 8, so 53. -3 comes next. -32 add 5 is -27. 36 take 40 is -4. And then comes just simply 15. Now here, what do we do? We're going to get a 2 by 2 matrix when we do the addition. And then we have to multiply it by a 2 by 1 matrix. So we're going to get a 2 by 1 as a result. Let's just do the 2 by 2 addition. -4y add 2y is -2y. 2y add 6 is just 2y add 6. 4 in this entry here. 3 add 2x in this entry here. And that has to be multiplied by 5, -5. Just let in some more light. That's fine. And now, -10y. Take 10y, so -20y. Take 30. Then, -10y. excuse me, this is just totally mistaken. We now have the entry on the top. So now we can just do 4 times 5, so 20. 20 take 15 is negative 5. So negative 5 take 10x. And that's fine. Here we shall do the 2 by 2 matrix multiplication first, and then just take away this matrix over here, which is very simple. So negative 6y squared, take 6y squared, negative 12y squared, and then take 6y because of here. What next? 6xy squared, add x squared y squared. And then take away and then add 6. That's what it appears to be. Next, 2y squared, add 12y squared. So 14y squared. 14y squared, add 3y. Then negative 2xy squared. Take 2x squared y. Take y. Give an example of a matrix expression in which you would first perform a matrix subtraction and then a matrix multiplication. Use any numbers and any dimensions that you like, but be sure that your expression isn't undefined. So you know me, I'm going to choose the absolute simplest that's allowed. So, the absolute simplest would just be to make everything 1 by 1, like this. But probably don't do that because it looks like you don't really understand or you're sort of messing people around. Probably just give something a little bit more typical, like 1, 2, 3, 4. Take 5, 6, 7, 8. And then multiply that by 1, 2, 3, 4. No problem. And we know that that's defined and it's going to give us a 2 by 2 matrix. Let's see. In the last one here, we've got A, B, and C, which are matrices. And we have A, open brackets, B add C equals A, B add CA. That's what they say anyway. You would think it would be A, B add AC. But let's see. They're saying right here, is this always true? Is it sometimes true? Or is it just outright false? It's sometimes true. It's definitely not always true because matrix multiplication is not commutative. It's not commutative. You can't swap them around. But it's also not always false. I mean, imagine if I had the zero matrix. The 2 by 2, let's just say a 2 by 2 matrix whose entries are all 0. And let's say that A, B, and C are all the 0 matrix, because it didn't say that A, B, and C have to be different. Then this would be valid. So in other words, it's sometimes true. And I think that completes the lot. Okay, I'm not sure how to let go of this. Right. Maybe I'll just use my trackpad. So I did everything I intended to do. This is my first try of streaming. And the reason why I'm going to do it is because it will save a huge amount of data on my computer. Rather than me just making videos where I'm just simply working out math problems in computing and calculating, I could just stream it. That seems to make sense. So yeah, I'll do that. And I will take a healthy amount of breaks. I won't stream for like 3 or 4 hours non-stop because my hand would give up essentially, and it would also damage my eyesight. So I'm not going to do that. So I'll take a lot of breaks. I really do hope that there's some kind of like pause button of some kind. But who knows? Maybe I can work that out. I'll learn more as I go, obviously. Okay, that's it for now.